Okay, Assalamualaikum and welcome to the video. In this video, we are going to get into the third topics, momentum and impulse. So as you can see in the previous subtopic, uh, the way we deal with motion is we use several quantity to quantify the motion. Okay, one of the quantity that we use to quantify a motion is displacement. So a vector displacement S, and then from there we also measure the time, all right, for the object to move, the time for the object to travel a distance of S or displacement of S, and then from there we derive another quantity which is the velocity. From there we derive the quantity of velocity. Velocity is just displacement divided by time, and then from there we also have acceleration of an object. All right, so this is the quantity that we have used before to quantify the motion of an object. All right, so in these topics I'm going to introduce another two, okay, which is the first one is momentum p, which is also a vector. So S is a vector, V is a vector, A is a vector, P is also a vector, and then another one is the kinetic energy. So kinetic energy. All right, so this is the new quantity that I'm going to introduce to you today, momentum and kinetic energy. All right, so the quantity displacement tell us how far the object has moved, and then the quantity time tell us how long the car has moved. All right, and then the velocity. So the velocity tell us how fast an object is moving. All right, and then acceleration is how fast the velocity is changing. All right, so velocity is changing. All right, so that is displacement. So every quantity tell us something about the motion. So what is momentum? Momentum is telling us how much motion we have. So it tells us how much motion we have. So I'm going to illustrate to you the idea here. So basically you can think of momentum as amount of motion. All right, and then finally every object that has velocity, it's going to have with it the kinetic energy. All right, so you can calculate the kinetic energy of a moving object using the equation half mv square. Okay, we are going to go to the next slide to explain what I meant by amount of motion and the value of momentum. I want to show you or take you to one of the most interesting event where we have people chasing cheese. So basically what happened is, if you can see in the picture, I've circled the cheese. So this is the cheese. They roll down the cheese down the hill, and then these people here will start chasing the cheese. All right, I'll leave a link to a video on this event in the description section of the video below, and then you can look at it yourself. So this is how the race started. So everybody is trying their best to chase the cheese, the rolling cheese, and then after a while, what happened is everybody is now rolling with the cheese. All right. So what happened is, as you were running down the hill, you start to gain velocity. So then the amount of motion that you have increase. So when they start gaining speed, so what they have gained is they have more motion. So it is becomes more difficult to stop. That's why you are seeing this kind of situation happening here, where everybody just falls down on their back, all right, and they are struggling to stop themselves. So if you look at the picture that I've put here, you have three objects here. First is the person here. So this is the person. Second is the wheelchair. And the third is the rolling boulder. Alright. So we are only going to look at the first and the third object. So as you can see here, when you are running down the hills, you start to gain your amount of motion start to increase. So the way we quantify that amount is by the quantity of momentum. So if you look here, the amount of motion, alright, if you compare the person that is running down the hills and the boulder, you will see that it is more difficult to stop the boulder from rolling down the hill. So we'll say that the boulder has more motion to it. So the way we quantify that amount of motion is using the momentum. So if you look at, let's say, the mass of the person is probably around 80 kilo, and the mass of boulder, let's say, about maybe 500 kilogram. So the person will have less motion compared to the boulder. Okay, so if we calculate the value of the motion or the momentum of the person, let's say they're both moving at um, 0.5 meter per second. So let's say both have the same velocity, 0.5 meter per second. So if you calculate the momentum of the person, you will get 80 times 0.5, you will get 40. So because it is mass times velocity, the unit for mass is kilogram, unit for velocity is meter per second. So the unit for momentum is kilogram meter per second. So on the other hand, for the boulder, the momentum is going to be massive because the boulder is more massive than the person. So if we times with 0.5, so we'll get 250 kilogram meter per second. So just by looking at the value, we'll say that the boulder has more motion into it. Alright, so that is the idea of momentum. I hope you will starting to get the idea of momentum. Now, let's say we have a car that is currently moving at a speed of at a velocity of 25 meter per second, and then he sees a traffic light, and then the light turns red, and so it needs to stop. So let's say the mass of the car with the driver is 1000 kilogram. So the amount of motion that the car has at the moment is given by the value of the momentum. So the momentum of the car at the moment is 1000 times 25. It's going to be 25,000 kilogram meter per second. So now, when the car sees a red light, it needs to stop. So the driver hit on the brake, and then the brake will apply a braking force to the car, and it's going to slow down the car until it comes to rest. So now the velocity of the car becomes 0 meter per second, and the mass is still the same, 1000 kilogram. So now the car has no motion. Alright, so the motion is 0. So we can see that from the value of the momentum. So the mass is 1000 times with 0. So you get a momentum of 0 kilogram meter per second. So as you can see from this example, to change the momentum, the amount of motion that an object has, you need to apply a force. So now if we calculate the change in the momentum, so delta P, so the symbol delta here represent uh, the change, alright, so change in momentum. To find the change, we have to minus the initial momentum from the final momentum. So P final minus the initial momentum. So final momentum is 0. minus the initial momentum is 25,000 kilogram meter per second. So the change in momentum is negative 25,000 kilogram meter per second. Okay. Okay, now the value is negative 25,000 kilogram meter per second. I really hope that the negative sign doesn't throw you off. You have to remember that we are dealing with vector quantity. So the negative and the positive, the sign of the value only indicates the direction. So the negative sign here only is telling you that the direction of the change in momentum. So if it is in the negative direction, that is all. So the magnitude of the change is 25,000 kilogram meter per second. You need to be comfortable with negative value. So it is not a scalar value, it is a vector value. So the negative is the direction of the change. Okay. So I'm going to highlight the value here. So this is the change in the momentum. So I repeat again, for you to have to change the momentum of the object, you need to apply force. Okay, apply force will result in change in the momentum. Okay, we have calculated the initial momentum of the car, which is 25,000 kilogram meter per second initially, and then after he sees the red light, the momentum of the car, the driver step on the brake and change the momentum of the car into 0 kilogram meter per second. So the momentum has changed. So and then the change, we have calculated change. So the change is going to be final minus initial. So it's going to be negative 25,000 kilogram meter per second. So that is the amount of change, and the negative sign indicates the direction of the change. Alright. Now we are going to look at two types of situation where the car come to stop in a very short period of time, meaning that the driver steps on the brake really hard and stop the car in a very short period of time. So we have delta t, so the time taken for the change to happen. Alright, so I'm going to correct the t. So we have delta t. So the delta t, the time for the car to come to stop is either short, very short, or it can be very long. Either we have a short time or long time. The short times tell us that the braking force, so F braking, B-R-E-A-K-I-N-G, force braking is huge. So for a very short intervals, alright, meaning the car comes to stop almost immediately, means that the braking force is huge. If the car takes longer, meaning that the braking force is smaller. So F braking will be smaller. So the factor that determine whether the braking force is huge or small is the time for the change to happen, right? So I'm going to highlight the time here. Alright, for the time for the change to happen will affect the amount of force that needs to be applied to stop the car. In the previous slide, I've shown to you how we can calculate the change in the momentum of the object, so delta P. So delta P is change in momentum. So now I'm going to introduce to you another quantity that we use, which is impulse, so J. So J is basically change in momentum. impulse is change in momentum, and we define impulse as the amount of force that is applied time with how long the force is applied. Alright, and the value of force times T times delta T is actually equal to change in momentum. Alright, I'm going to make it closer. So I'm going to correct that. So equals to change in momentum. So to change the momentum of an object, you need to apply the force. Okay, you need to apply a force to change the momentum of an object. Remember the case with the car? So the car has changed the momentum from 25,000 to 0. So the way we change the momentum of the car is by applying a braking force. So and then the time here is the most important factor that will determine the magnitude of the force that's being applied to the delta t here. So if the change happens in a very short period of time, meaning that your force is huge. So that sums up what we have discussed before. I'm going to use a different color. Okay. Alright, so if we rearrange the equation, we get the force that is applied equals to change in momentum over delta t. Means that if your change in momentum happen in a short period of time, so delta t is small, means that the force that you are applying to the system, to the object, is huge. And for the case where the change happens slowly, so delta p over delta t, and delta t is big, alright, so the change happens slowly, means that the force that is applied is small. Alright, so the equation J equals to F times delta T equals to delta P sums up the relationship between the change in the momentum to the amount of force that is applied to the system. Alright, I repeat it again. To change the momentum of an object, you need to apply an external force. You need to apply a force to the system. The most important factor that determines the amount of force that needs to be applied is delta T. Alright, how long the force is applied. The force that you need is huge for the change in momentum to happen in a very short time. So this relationship or this equation is known as momentum and impulse theorem. So this equation is actually the momentum and impulse theorem. It gives the relationship between F and delta P, and the determining factor is delta T. Alright, okay, I'm going to do one last examples where we have a ball that is thrown to a wall and then bounce off the wall. So I'm going to draw you the wall here. Alright, so we have the ball that is thrown to the wall. Alright, let's say just to make the calculation easier, I'm going to take the mass of the ball as 1 kilogram meter per second, and the velocity of the ball is 2 meter per second. So now the ball hits the wall and then it bounces back off the wall. Alright, so let's say it bounces off with the same velocity, v equals to 2 meter per second. And then the question asks you to find the change in the momentum. Alright, remember, change in the momentum is P final minus P initial. So first we have to calculate the final momentum. So P final, P is a vector. So the mass is 1 kilogram, so 1 times with negative 2. So why I'm using negative 2? Because of the direction of the velocity is to the left. So I'm taking the velocity as negative 2. So negative indicates the direction. So I'm going to have the momentum at -2 kilogram meter per second. Alright, and then the initial momentum is 1 times 2. So 2 is positive, so you have 2 kilogram meter per second. So the change in the momentum is -2 minus 2, so equals to -4 kilogram meter per second. So the change in the momentum when a ball is bounces off the wall is -4 kilogram meter per second. The negative at the front is just telling you the direction of the change. Okay, don't worry too much about the negative. So the negative is the direction. So the magnitude of the change is 4 kilogram meter per second. Okay, so you have a change in the momentum of the ball. So you can, from there, you can calculate the amount of force that is exerted by the wall on the ball by dividing the change to the impact time. So let's say when the ball make contact with the wall, let's say the impact time is 0.1 second. So that is the amount of time where the ball are in contact with the wall. So the force that is applied by the wall to the ball, alright, so the force we are using the momentum impulse theorem. So force of the wall on the ball times the impact time is 0.1 equals to the change in the momentum, -4. So the force applied by the wall on the ball is 40 Newton negative. Alright, the negative is just telling you the direction of the force. So the direction of the force is going that way. So the same direction as the negative velocity here. Alright, so that is the direction of the force because we have the negative sign there. Alright, so the negative is just telling you the direction of the force, but the magnitude of the force is 40 Newton. So that is the amount of force that is applied on the ball to change the momentum of the ball from 2 kilogram meter per second to -2 kilogram meter per second in 0.1 second. Alright, so we change the momentum from 2 kilogram to -2 kilogram in 0.1 second. So the amount of force required for this change to happen in this particular time is 40 Newton. So a 40 Newton of force is applied in 0.1 second will change the momentum of the object from 2 to -2. Alright, I think that is all for this section. We are going to continue on the module and do some examples there and the aura questions. I hope it helps you to understand the concept of momentum and impulse. Alright, and then you need to be very comfortable using these terms to describe motion and collision and force. So that's it for this video. Thank you very much.